Hi everyone, welcome back to Java 1 for All. In this video, we are going to start talking about generics, and I think it's time for us to create a new package. Alt insert package z generics dot test, and let's create a class called generics test01. So let me show you how things were done until Java 1.4 and why they introduced generics. So we have a list, and as you can see, when we don't tell the type of that list, we can just add anything. So the add accepts object, and since everything is object in Java, you can add string, you can add longs, you can add custom objects, and so on. If you are developing for some time now, you probably understand what kind of problems these can bring to you. It's pretty fine, just adding and everything is stored in memory. But the problem is when you try to use that list back, because if you are creating a list, there is a very high chance that you are going to use that list for something later. And of course, we have our for that we, for example, want to retrieve everything. Since we don't know what kind of object is inside that list, we just have one option, object. So we can accept everything, and then we can iterate over this list. Now, if you are just printing the data from that list as a string, which almost never happens like this, we are fine. Well, we can get all the values back, we can see what's happening, we can see what's inside. But the problem is if you want to use the object. For example, if I wanted, for example, to compare two customers, how do I know that this guy is a customer? I have to filter, or I have to make sure that this, for example, is a customer by checking if O is an instance of customer package by collection. And then we could get cast working here to then do something with our customer. And that would be the same thing for everything. Strings, longs, or any other possible object that you are adding to this list. So basically, the guys were thinking, the guys from Java were thinking, okay, how can we actually do something here that will not break all the devices, all the servers that are running Java applications? And this is the thing with Java. Everything they do, they try to keep backwards compatibility working flawlessly. And that's one of the reasons why it took so long for the language to evolve. So you saw new languages coming up very fast. For example, Kotlin, TypeScript, and Java, it used to be going on a slower pace. And then they came up with something pretty clever. So they said, well, we can keep everything as it is in the JVM, but we can do some checks, for example, when we are compiling. So generics is something that only works at compilation time. So for example, when you do this and you tell the type, okay, this is a list of strings. Basically, it only works, it only checks when you are compiling. That's why we get these errors here saying, hey, you need to change this object, the value that you are putting inside that list, because I can only accept strings. Now, the syntax up to 1.5, 1.6 was like this. You used to have to tell in both sides the type, but then 1.7 they changed because this is always the same. It needs to be the same. So they said, well, if it needs to be the same, you don't have to tell. And this is the syntax being used today. And then, of course, if you have a type for that list, your add is also using that same type, and your for can also be typed. So for example, you know for sure that this O is a string. So since this is happening at compilation time, when this code reaches the JVM, there is nothing saying that this list is typed. And this is called type erasure. That's basically what's happening. You are erasing the type after you compile this code. And to show you, I can do something like this. Imagine that we have a method that's going to add stuff to a list. So for example, I can get a list here. I will call any list, and I'm going to add elements to this list. So basically we are passing the reference, and then we are going to use that reference to add stuff that inside. And I will create here a customer. So basically I will add to this list the customer that I'm passing. So any list dot add C. Okay, I don't know what kind of list I'm going to pass as reference here, but I'm just going to accept everything. That's what this method is saying. And we can do this. Add, I will say, okay, my list, that's technically a list of strings, and I will pass, I would like to add a new customer inside. So do you think this code is going to work? Because there are no compilation errors. Let's execute. Ctrl Shift F10. And as you can see, it's working and it's compiling and it's executing. If I copy this for and I add down here, we will get one exception. Where are we going to that exception? Right here at line 20. Why? Because it's going to try to cast the customer into a string. Of course, they are not compatible. That's why we have class cast exception. But if I change here to object, it's going to work perfectly fine. We have two different objects inside our list, string and customer. So you still have to be careful. That's why we have some warnings. IntelliJ say, hey, you should not add to the list something that's not typed, and you get the warnings here and here. So the best thing to do is to, every time you create a list or any collection, you type that collection. So this is just one introduction about generics. In the next video, we are going to actually do some custom code with generic. So see you in the next video. Bye.